Hello, I'm John Moll with CrystalStream Technologies. I'm here today to give you a demonstration of how our product works and hopefully answer some of your questions about water quality. But one of the things that's always important to cover up front is, why are we sitting here? Why would anybody want to put a contraption like this out in a stormwater system? And why is that the EPA passed the Clean Water Act in 1972. They amended it with the Water Quality Act in 1987. And those two pieces of legislation have been turned into state permits and regional permits, local permits that govern how we treat the water, the stormwater that runs off the site. There's an even more important reason to an engineer or to a contractor of why we're here today. That's a lofty goal to meet the EPA mandates, and we want to do that. But the real reason can be summed up in one word, and that word is permit. We are here today because Crystal Streams have been permitted on job to perform a task of water quality. Sometimes in lieu of land-based systems, sometimes when there's no other good system that is available. So realistically, I understand if we are not permitted in your jurisdiction or in your state, it's not really a good reason for us to do a lunch and learn. So we want to talk about both pieces of this of the EPA's Clean Water Act, from the high end of how we're going to clean up our streams and lakes and rivers, and from the low end of how do we get our plans through at the permitting desk down at our local jurisdiction. There's while the state and federal regulations are important, and they're very important because without a permit you're not going to do your job, there's also an ongoing responsibility to the site owner. And often this is lost in the shuffle of getting that building built or getting that site graded. That responsibility to the site owner is important because the engineer is going to be gone, contractor is going to be gone, inspectors are going to be gone, EPA is going to be gone, and the site owner is going to be left with a system that's supposed to intercept pollutants, may need to be cleaned, may need to be maintained. And when that violation gets written, it's going to be written to the site owner for not complying with the Clean Water Act. That is why at CrystalStream, we've decided that we want to take that lofty goal, along with the goal of getting a permit, and we want to join those two together so we're actually effective and we're actually getting what we need done as far as cleaning up our streams and waterways. We kind of say if you're going to do it, spend the money, do the plans, get the permits, write the laws, might as well clean the streams while you're at it. And that drives the very basis of what CrystalStream Technologies is. One of the things that we argued 20 years ago was, is this a real problem? I mean, if you watch the water coming off a parking lot, especially if it's been raining a while, it looks pretty good, it looks pretty clear. Maybe a leaf every now and then or something coming down in it, and we said, it's probably not that big a problem. We argued that. We thought, and the EPA thought, that there was 500 to 1,000 pounds per acre per year washing off these sites. They did a famous study in the 80s called NERP, National Urban Pollutant Database, and they quantified what was coming off the sites. Well, they missed that number for a lot of reasons, and we're not going to go into all those today. You should understand there are webinars and other things available from CrystalStream that are not product-oriented that will help you understand the Clean Water Act and the nature of the problem. But let me assure you the problem is real. It's real because of 6,000 maintenance operations we've done in the field. We are averaging close to 3 tons, 6,000 pounds per acre per year. So in other words, the problem is 10, 12, at least 5 times as big as the EPA envisioned when the Clean Water Act was written. So we know the problem is real. We know we need to get a permit. We know we have a responsibility to our owner for ongoing operation of this system. And that's why CrystalStream Technologies has taken a little bit different approach. Most of our shirts have on the sleeve design, installation, and maintenance. And it's what we live by at our company. And BMP design is an important thing. Something as simple as a silk fence. I use silk fence as an example because everybody understands what a silk fence does. Every citizen out there has seen the black cloth with the stakes along the side of a property. And it's meant to keep silt from leaving the property. If you design a silk fence properly, and very, very few silk fences are designed properly, it will stay on grade. So the water goes through it, we would call it sheet flow, an engineer would. It doesn't accumulate at one place. If you run silk fence up and downhill, all the water runs to the low point. all the silt goes to the low point, and the silt fence fails. The idea is to catch silt. It catches no silt. So, if you design it properly, it has a chance to work. We take a machine like this, and many of my competitors and others think of these as a black box. Oh, we don't need to design. We would just issue a brochure, mention a flow rate, and that's what you put out. So design's important, but let me say, once that silt fence is designed properly, and it wiggles around the property to stay on a certain grade, contractor walks up, takes one look at that wiggly fence, takes one look at his ditch wedge and goes, that's nuts. Straight down the property line he goes, uphill and downhill, seen time after time. So just designing it properly doesn't guarantee that you're going to have a silt fence or a CrystalStream that's going to work properly. You have to have it installed properly. So if no one checks, you may do the world's greatest design job on your BMP. But as far as functionality, as far as your owner goes, as far as getting a fine for putting silt out in the street, might not quite work. Thirdly, what does a BMP, best management practice, do? It's designed to intercept and hold pollutants. And if that's true, if it works at all, it's going to slowly fill up over time. Like the silt fence, we'll gather silt behind it over time. And if you don't remove that silt, what's going to happen? Well, the silt fence over time will rot, and the silt will go downstream, or the silt will build up to a point where it will keel over, and all of us have seen this in this business, certainly. So, design, installation, and maintenance is that little three-legged triangle, or stool, if you will, or support, that supports BMPs and how they operate. Let me tell you a little bit about design. Design for what we do is not just knowing the flow. Now, that's a key piece of information that we have to understand, that we have to know. When you know the flow coming into a device, 3 cubic feet per second is one way engineers like to talk about a flow, for example. When you know the flow coming into a device, that's not the only piece of information you need. A couple things you need to know. 3 CFS coming in at 1 foot per second this fast is much different than 3 CFS coming in at 5 feet per second this fast. And if you were building something like this with baffles and walls and sediment in the bottom, everybody understands that the velocity of water tends to disturb sediment, tends to break metal pieces, tends to cause problems. So we not only want to know the volume of flow, we want to know the rate of flow, we want to know the velocity of the flow, we want to know some other things. Knowing that flow and understanding how to treat that flow is a key piece. I would invite you to think about if you were washing off a patio with some sand on it where you've been planting plants. Sand moves great with a hose. As long as you're close to it, you try to wash it all the way across your patio. As the velocity decreases, the sand falls out, and you have to get closer with the hose because the flow slows down. Velocity equals movement. Movement is an important thing for how this machine works. We have to have the material move to the machine, and we want to have it stay in the machine. So design is more than that. It's even more than just knowing the velocity of the flow and the amount of flow. How deep is the water in the pipe? We talk about that as the hydraulic gradient. This machine has an obvious limit. The water gets deeper as we run it faster. All of them do. There's a point at which this entire system fails. And that hydraulic gradient can happen in a lot of ways. One, the smaller pipe we put in back, the deeper the water will get. That's pretty simple. Every engineer understands that. It's called a head, building up a head. The bigger the pipe we get, the less deep the water gets. Okay? But not just the size of the pipe, which is important. There's also what happens downstream. Is there a pond downstream? I've seen plenty of systems designed, and they were designed by reading a brochure and going 3 CFS. That'll be a Model 2000. And the salesman quite happily sends in a quote, he sends in a stock drawing. Nobody looks at the design in the system and realizes there's a 6-foot deep detention pond behind it. And the unit's going to flood immediately, and the system's not going to work properly. Design means understanding hydraulics. It means understanding fluid dynamics. It means a lot of things. At CrystalStream, you're not out on a limb as an engineer with a product brochure and a salesman who couldn't tell you hydraulic gradient, who could not tell you boundary flow from laminar flow. You're dealing with engineers, you're dealing with scientists, you're dealing with people that have done the research to properly understand design. So design is not just picking the flow off of a chart. The maintenance, the installation of these units is also critical. Today we use suppliers who receive our parts, assemble our devices, deliver them in the field. Typically these operators that do the physical installation of a unit for us are folks that have set hundreds of volts. They understand the need to be level. They understand safety on the site. Instead of you trying to, as an engineer, manage installation, understand crane distances, booms, jibs, counterweights. This is done by professionals. But installation doesn't stop when we get a vault down in the right place, oriented in the right direction. We see lots of competitors' products put in backwards. Out of 1,500 volts, we're embarrassed to say we had one put in backwards one time. We and the contractor agreed that that was downstream, and it turned out that that was downstream. And we moved the parts, and it's a fairly simple thing in our device to do that. But we see a lot of competitors' products put in backwards because nobody understands the installation. And our folks do. Not only do we understand it, we check on the device and we write a letter at the end of the job in conjunction with the engineer if the engineer requests, and we think it's a good thing for the engineer to request, and the manufacturer will say this CrystalStream device was manufactured properly, installed properly, it's clean, and it's operating correctly on this day, November 1st, 2012, so that the contractor is finished on the job and doesn't have to worry about it anymore. He's got the manufacturer certifying that it was done right and is ready to go. Now, the owner of the site owner has received a device that's clean, operating properly, and ready to go. So at least he has a chance to do what? Design, installation, maintenance. The machine's going to operate properly because it was designed properly. We thought about velocity. We thought about the downstream. We thought about what needed to be done to have a functioning machine. Remember, you can get a permit with a CrystalStream, but the lofty goal is clean up the rivers and the streams and take care of our owner at the end of the day. So we've got this machine that's easy to maintain. We've thought about that. And it's ready to maintain. Now, there's a couple things that recommend maintenance. First of all, it needs to be done. Second of all, it's a law. But most importantly, that maintenance can keep the owner from ever having a problem downstream. And it's very important. And there's a physical piece that will incentivize that owner to do the maintenance. What is it? Unlike any other product in our industry, CrystalStream Technologies offers a 5-year warranty on our device. If we write that letter and that owner hires a maintenance company, parentheses, we do maintenance, thank you very much, and we'll be happy to have that maintenance contract, but it doesn't matter. Use rotary, use however you want to. But maintain that unit and have evidence that you've maintained it. It's our job to fix it if it breaks. It's our job to replace the basket if it gets torn up by a flow that we did not anticipate. It's our job to make sure that owner, ongoing, maintains a system that functions, keeps them from getting a notice of violation. So we want to be there all the way through this job process. That's why we consider that the jurisdiction is a customer of ours. We respect the people who say yes and the people who say no and the people who say maybe, and we advocate for the use of our products so that you can get a permit here at your engineering firm. But at the same time, we respect you as engineers. Why? We do the designs. You'll get a sheet, a specification specific to your locality that your reviewer is going to know and understand. Might even line up perfectly with his checklist if he's a checklist type guy, so that you can get your permit. So then we respect the contractor. Why? This excavation is 3 to 4 feet below the invert of the pipe, as opposed to many of our competitors 14, 15 feet below the pipe. You got to think about rock. You got to think about water table. Going back to design for a moment. What about buoyancy? What about the water table? What about the compressive strength of the concrete? You don't have to worry about that. We partner with people who understand, local precasters who understand that, and we get these vaults in correctly. That's a piece of design. When this system is in place, at the end of the day, it's guaranteed to function. It's watched, it's repaired, and it's a sustainable solution for the owners. And as engineers who want to appeal to the long-term viability of your client relationships, That's why we think it's important to use CrystalStream Technologies. I would submit to you that any competitor that walks into your door, or anyone that walks into your door with a better silk fence, needs to understand the role of design, installation, and maintenance for every single BMP that's out there. Don't put it down the hill where someone can't get to it. Don't put it in the drive-through lane in a 24-hour burger doodle, because they're not going to be able to get to it. Think about how that machine is going to function. Think about how it's going to be maintained over time. Everyone always wants to know, how does this thing work? We've got 9 patents you can go read. The numbers are on our drawings. You can look them up. Part of getting a patent is it's a two-edged sword. It protects you from people copying your technology, but it also exposes it in great detail to every one of your competitors and the arguments you made to show why you're innovative. But I can boil those 9 patents down into just a few moments that will give you an excellent explanation of how this thing functions. And then I'm going to put some real pollutants in here. This came out of your parking lot. We call this local data. It's a mixture of the things we find washed into stormwater. But in general, how this thing works is, we talked about velocity moving material. The principle of the CrystalStream is that it's an energy disconnect. And what that means is, the velocity as the water comes into our device is going to be the greatest velocity that will be encountered from this wall of our device to this wall of our device. There is no place in our device where the water will go faster than it goes when it comes in. There's no place in our device that will go that speed until it gets into the pipe behind our device, where it will regain its original speed, considering the pipes are the same size. So we bring the water in, slow it down some more, and in the back of our device, it's approximately, and this is a model, a 1/8 scale model that is in proportion. So I'm not showing you some plastic trick here. This area is 10 times bigger than the area of this pipe. So the velocity coming out of our device is 1/10 entry velocity. As engineers, you probably know this, and maybe you don't know this, but I'm going to mention a couple of facts to you that might give you some insight as to how to build a BMP. Okay? If a storm achieves a velocity of about 1 foot per second in this pipe, the water will be moving up at about 1/10 of a foot per second as it exits our device. 1 foot per second will scour 60 micron particles. I don't know if you're familiar with microns. I'm not. I'm sure almost everybody is not. When I asked the former head of MPDES, the top guy in the EPA, how big the material, which is graded material, in this little jar was, you can see it takes a minute to settle. He said 4 microns. He was close. He was only 96 microns off. This is approximately 100 micron sand. Okay? Material this big will wash into this device at 1 foot per second. It has no chance of coming out of this device at 1/10 of a foot per second. What would get it out of this device? A flow 10 times bigger than the entry flow. 10 feet per second here. A geyser. A huge amount of energy it would take to achieve that exit velocity here. Now, if you were talking 100 microns, 60 microns, 30 microns, let me give you some statistics and facts and numbers. These are facts from third-party studies done and paid for by others. You'll have people tell you, oh, I'm sure I've got a third-party study, meaning they hired a lab. Now, I hired a lab too, and I've got a lab study. And if I had gone to that lab and said, my device works at 2 CFS, and it turned out it didn't, I'd go, run that thing again. I might slow it down to 1.5. I might slow it down to 1 foot per second. I might not publish that study at all. It happens all the time. Back to the drawing board. We don't want to use that lab again. A third-party study is where someone takes your device and says, I'm going to test it. I'm going to pay for it. We'll talk to you later. They literally locked my device down in Griffin, Georgia when the EPA tested it. They locked it down. They literally locked it down when the USGS tested it. We've been tested in Highlands, North Carolina. Every time this device in the USGS test, the device achieved somewhere in the 70s for solids removal. If you count all the solids in the device, probably over 80. It was certainly over 80 in the test done by the EPA in Griffin, Georgia, 89% removal of sediments. Some people quarreled with those tests because they use a method called SSC of analysis. SSC is actually the correct analysis method. But they said, boy, we really want to see you use a TSS analysis. So we did. I say we did. The North Carolina Department of Environmental and Natural Resources did. We got a 96% removal when looked at with a TSS type of analysis. So, we've got the empirical numbers to say that we work. But here was something that's more interesting. I've got some, you saw this sand settle out, even though it takes 2 or 3 seconds. And that's about the right number to settle a couple of inches for this size sand. I've got some milk here I'm going to pour in this device a little bit later. Clay, by definition, never settles out of water. So, since water here is moving, and even if it weren't, we put real clay in here, it would sit for days and days and days and days, and it would never, ever, ever settle out. Silt settles out. Believe it or not, 5 micron silt will take about 2 weeks to settle this far. 2 weeks. 100 micron sand take about 15 seconds. A bowling ball will take about a half second to sink that distance. Okay, it has to do with the size of the material and the density. But in Highlands, North Carolina, almost 8% of what was in our device was clay sized. How in the world does that happen? It's impossible. Physically, it's impossible. This is why a lot of academics oppose the use of manufactured treatment devices. Because they'll sit in their lab and go, well, clay doesn't settle out. Silt takes 2 days. This thing can't work. And I just go, come here. Why don't you take a look at what we got in our device out here. And we have 8% clay. We generally have 5 to 8% clay in our device. And why? Stormwater is not nice, pretty, round, graded 100 micron sand. That's not how it works. It's got cigarette butts and bottle caps and pieces of plastic and dirt and oil and fertilizer, antifreeze, maybe some salt we put down last winter when it iced over up here. Stormwater doesn't work like that. All that clay, anybody's ever dealt with clay knows clay's sticky. It attaches itself to other particles. It attaches itself to paper. We get trash and debris out of here that you can literally take vegetative material out of my device and rub it in your hand. And then you can't get the gray dust off of your hands. And that's clay-sized particles that are engaged with other particles coming into a device. So, how these things work is badly misunderstood. And one of the things that's important with a CrystalStream, as opposed to a lot of land-based systems, is when we get to the maintenance part, we clean ours out about every 6 months. We have some we clean out once a year. We have some we clean out 4 times a year. And why? A dentist office of 1 acre will look the same to a reviewer, 1 acre of impervious, dentist office. Oh, the flow's the same. Let's go to the chart and get the Model 2000, that'll work. Or let's put it in a wet pond, that'll work. But see, that site is the same to them as a gas convenience operation. And they're not the same at all. 12 trips a day, 1,200 trips a day. No gas in the oil, lots of gas in the oil. Nobody's ever going to take a pressure washer to get the oil out of that dentist parking lot and wash it down with detergent. It's going to happen here every time, maybe even every day. Completely different problem. So we understand that a piece of design is understanding what you've got coming to you. This is material out of your own parking lot here. There's some Energizer battery. Yes. This is the holy grail for a water quality guy. This is about, in microns, we're talking about 30,000 micron particle size here. And people go, oh, that big stuff doesn't carry any problems. This is full of alkalines, full of acids, full of metals. I mean, you can read on the label what's in there. This falls out in your parking lot and you've got a problem if you have a device that doesn't catch it where you can remove it. Okay? When you clean a CrystalStream and other manufactured devices, they're brand new. They're brand new. It's not like having to reseed the bottom of a pond or put new sand in the bottom of a pond. These things are ready to go again. So this battery might hit the parking lot out here. And if there's a CrystalStream, you can rest assured within 6 months, guess where it's going to be? In the landfill where it belongs. If it falls in your wet pond or your sand filter, guess where it's going to be? In the environment until it finishes rotting, decomposing, and discharges all of its pollutants out to the environment. So I put the material in here. Now I'm going to tell you, the EPA did a thing called a surrogate. You may have heard of surrogate mother. Some of you might not be that familiar with what happens. A surrogate mother is someone who carries a baby for someone else. The EPA said, you know, there's 300 things mess up our rivers. And they started going through polyaromatic hydrocarbons, benzene. They just got a whole long list of them. And you really have to be a chemist to understand most of them. They said, we know you can't test for 300 things. We'll tell you what you do. You just test for this. You just test for sand and solids. And if you get out 80% of that, we're going to pretend you're good. Now that's a pretty silly system, but let me tell you the truth. We have found now, 40 years later, it really is pretty much the truth. Almost all the pollutants attach themselves to the particulate matter. So if you do get out 80 or 90% of the particles, you're probably doing a pretty good job. But to save everybody a lot of trouble, we have boiled these 6 types of pollutants down, these 300 types of pollutants down to 6. And those 6 are dissolved chemicals, is the first. A dissolved chemical would be like putting salt in water. Now I have had people stand up with a straight face. Not so much my competitors because they've learned better, but people that will put in a sand filter or a wet pond and go, oh yeah, we've removed the dissolved chemicals, do a great job at that. You know, if you put salt water on top of anybody's pond or on the top of my device or anybody else's device, you know what you're going to get out of the bottom? You're going to get salt water out of the bottom. You are not going to find a little pile of salt in the middle that you could use at home and some distilled water coming out the back. It does not work that way. 100% of the dissolved chemicals that go into most BMPs come right out the other end. Dissolved chemicals are a problem. Now, and they're also important. Now, I will tell you, if you pour some red dye in here, in my device, and we measured the red, we poured in here, we measured the amount of red dye right here, and we measured the amount of red dye coming out, because I have some grass, some cigarette butts in here, there's going to be a little bit less red dye coming out the back that day. And people will go, oh, we have a 5%, 10%. In fact, I think they rate me at about 60% removal of dissolved chemicals. Now, I will tell you we remove them, but the way we remove them is show up with a vacuum truck and vacuum out of our device. The next day, after I put the red dye in here, if we put some clean water in here, guess what? It's going to wash that red dye of the cigarette butts, the Kleenex, and the grass. And they're going to show a little bit of red dye coming at the back. Go look at the Charlotte studies where they absolutely prove that nothing North Carolina recommends for a land-based system works. In fact, the CrystalStream had better effluent quality, better water coming out of it than any of their hallowed 85% assumed removal rates. But you know what? When they tested us and all the other manufactured BMPs, they almost always found there was more zinc coming out than going in, copper coming out than going in. Why? Because, in general, these things do collect that material. And on a clean storm, a clean day. Now, when do you want to test and sample a BMP? When it's moving at 10 feet per second, it's Armageddon? No. You want to wait till you got a little pitty-pat rainfall going, scoop up some water here, scoop up some water, and because the CrystalStream or the pond or the wetland gathered copper and zinc during those other events, it will show a negative removal rate. We don't manufacture it, neither do land-based systems. But dissolved chemicals are a problem. We have some good news about that. The latest research, our Highlands study, indicates that our coconut fiber filter and the material it collects is a one-way street. A one-way street for dissolved chemicals, meaning we collect them and they come in, but they don't go out. And they don't go out because there's a greater affinity, and you can explore this also in an upcoming webinar on our CrystalStream site. Humic or organic material tends to bind metals where it's very difficult to unbind it. And so we're finding over and over again today, and you will also notice that none of our competitors have a hydrodynamic separator with a filter in it. In fact, we should probably be called a hybrid unit because we're not just gravity. Okay? But we have found over and over again, and finally in Highlands, what they did was they cut swatches out of our used coconut fiber filter and compared it to a new one, and the results were astounding. I will leave it to you to examine that study and see exactly why we've been very effective at dissolved chemicals. I never really could say that before. I saw the test results, but remember, they might be negative or positive depending on when you test it. But what we've seen now is we can grab and remove. We remove pounds of copper and zinc, pounds, not ounces or grams, out of our device in Highlands, North Carolina. And that is material that was going straight to their water reservoir, harmful to humans, carcinogens, problems. So dissolved chemicals are a problem. I used to say we can't do anything about them, saltwater in, saltwater out. We're a little better than that today, and we've got some test results to prove it. The second thing would be true suspensions and milk. There's some milk in this cup. You can't see it, but there's milk in it. I promise I'll show it to you in a minute when I pour it in. But milk is a suspension, and suspensions do not settle out ever. And so if you've got a device that depends on settling, guess what? The suspension's going to go right through it. Bacteria, fecal coliform, is one of the top reasons streams are rated as impacted in the United States. And it's a suspension. It's suspended up in the water. They don't come out. So you got to attack them a different way to kill them. The third type of pollutant that is important, oil and hydrocarbons. We started this business based on collection of oil. We still today maintain spill protection in our unit. It's extremely important because the concern was 1 drop of oil falls out of each car every 3 days or something. The EPA did a wonderful study that said we probably get 5 gallons a year out of a 1-acre parking lot. And there may be 5 gallons a year fall out in a 1-acre parking lot. I can't dispute that. But I can tell you this, if it falls out and it's not raining, it's never moving again. And you've seen it in your own driveway. When oil hits the concrete or hits asphalt, that's where it's going to be. Why? Oil is made to coat and stick to surfaces. That's why we use it in our engines. It gives a lubricant. So the oil comes to us. We were hoping to catch a bunch of it right here in the middle with our oil collection reservoir, and we were going to sell it. And that was how our business started. Clark Musée and myself founded it on the idea that we not only would we get water quality credit, we'd have a little route, we'd run around and suck all that oil out of these things. We would sell it to the people that refine oil, recrack oil, and we were going to make a lot of money. We kept looking in there trying to find that oil, and it never showed up. But it did show up. In fact, there's oil right here. There's oil in this material that came out of the parking lot outside. It's stuck to these sand grains. I can actually put a sheen in here by scrubbing on this a little while. I can scrub some of that oil off, and you'll see it. You'll see it come in here. So we're not that good at oil if it's free, because the mathematics are that oil floats about 1/250th as much as things sink. And remember, I told you how long it took this stuff to sink. So catching oil while water's moving is kind of a crapshoot. But we have had 2,000 gallons of diesel oil spilled on one of our sites, and not a drop went downstream. And that's because CrystalStream incorporates spill protection. Once again, I'm not going to go into detailed engineering here. I'm trying to give you an overview of the product, but we collect the oil gathers, it depresses the water, it spills over in our reservoir. We have a certain amount we calculate on each site that we can intercept before it goes downstream. Myrtle Beach has about 22,000 gallons of protection of their beaches with CrystalStream product. So if they have a big accident, the tank trucks go down US 17 every day. They drop their whole load. We're not going to have a problem because there's a CrystalStream engine to intercept that. Okay? So those 3 things are the things we don't do so good at, but let's talk about the things we do well at. The number 3 pollutant, according to the EPA now, this battery falls into that category, as does this plastic Coke bottle cap. It's trash and debris. In fact, it's so important in California now, they have a 5 millimeter, that would be about 1/8 of an inch, a 5 millimeter TMDL, total mean daily loading limit, which means you can't put trash bigger than 1/8 of an inch out into the waterways of California. And so we perform a function where we put a mesh screen in between the water and the rest of our device so we can filter out that kind of material. Okay? So trash and debris is important. And why else is it important? Well, it's important because there's batteries in it. It's important because printed material, inks have chemicals, papers have coatings. All of these fancy cups, they may have a plasticized coating on the outside. All that material, when it's left in the water, it breaks down and it decomposes. And all those chemicals and materials go downstream. So trash and debris is very important. Plus the fact that I told you earlier what rides on top of trash and debris, clay, dissolved chemicals can get sucked up into that trash and debris. And I'll tell you when I show exactly how this operates in a moment, what we do about trash and debris. Essentially, we catch it here in our trash basket. We have a fail-safe program at the back, which is 3/4 inch thick coconut fiber that water, that trash cannot go through. You can imagine a straw wrapper, and you've seen them decomposing in a parking lot in the rain, little shreds. Can't catch it with 1/4 inch mesh, can't catch it with 1/8 inch mesh, you can catch it with 3/4 inch thick coconut fiber filter. So, trash and debris is important for a lot of reasons, but mostly because of what it carries, in addition to the fact it can decompose. The number 2 pollutant, according to the EPA, is vegetative material, like this grass here. Vegetative material is not so bad in the woods where it belongs, where leaves fall off of a tree, they fall to the ground, they rot, they decompose, they form a humus layer that actually helps retain water, helps keep moisture under the tree. It re-nourishes the tree because there's phosphorus and nitrogen in here, and it's a good thing. Then engineers decided that when we were going to do parking lots, we didn't want to leave them out there willy-nilly, so we put curb and gutter all the way around them. We put nice concrete structures in the corners and the low points. We catch all the water, we put it in a pipe, we band the pipe, we seal the pipe, and we make sure that everything that falls in that parking lot gets in the stream somehow, some way, because we're not going to let it go. We're engineers, we're anal, we want to control our water. Every now and then you'll see swales and ditches, which is a good thing. But the vegetative material that falls in a parking lot, you might think, well, it's a lot less than the woods. Do you realize this cannot get out of the woods? But it certainly can get out of this parking lot. The estimates are that when we pave a parking lot and we add landscaping and trees to that parking lot, which everybody wants trees around the parking lot nowadays, right? And we have landscapers that will take their blowers and make sure they get down into the catch basins. We probably put 100 times the nutrients into our streams that used to go into our streams, naturally. To make matters a little worse, we'll probably spray this grass with some sticky fertilizer so it'll last a while. Might put some pesticides out there with it. And as this thing rots and decomposes, this vegetative material, all of that goes into our streams. All the pesticides, all the poisons, all the phosphorus, all the nitrogen, at an alarming rate. So, vegetative material is extremely important to control. We control it again, putting it in a basket, and I'll tell you in just a second how that works. We also, you may ask me, what if it rots up in the parking lot? We've got this nice handy 3/4 inch coconut fiber in the back, and remember, it's catching organics. What do organics do? They have a great affinity for metals and dissolved chemicals and other things that we can't catch very well. So this is a system, not a single element system, a single element device that just depends on gravity. That's why you'll separate us from the pack, so to speak, when you think about CrystalStream. It's not only the fact that we understand how to design, we understand how to install, we offer maintenance. It's the fact that we're separate from the pack on the other end, and that we actually have a system, not just gravity, that processes these pollutants and gives a better success. What's the number 1 pollutant in the world, according to the EPA? This doesn't look very dirty, but if you take a look at some of this other stuff, it looks mighty dirty. This is what really comes out of our device. This is black from organics and from oil, from asphalt, coarse wear. It's very highly varied in the particle size. Some of it's aggregate from mixing asphalt and concrete. Some of it comes off roofs. Some of it comes out of planted areas. But this material carries with it, if we didn't do anything else, this particulate material carries with it most of the pollutants. We coat our sand with asphalt, which is essentially petroleum products, petroleum-based products. And we make a mix out of it, and we're astounded that we have a lot of hydrocarbons in our sediments that come off of our sites. We go out to our road, and we take plasticized paint with reflective metal in it, and we spray it all over our road, and it wears off. I've told people that before, and I said, next time you're at a pedestrian crossing, take a look at the paint, and you can see where it's worn from the tires going across. All that material goes into our storm tires, all of it. Okay? Most people don't have a method for collecting that type of material. That's what we do. So I'm going to tell you quickly how this works. I'm going to pour some milk in, and I'll take some questions from those of you that are interested, or may want to stay afterwards and ask me some questions. But let's talk about the CrystalStream design from front to back and what we intend to do. We have a trash basket. This one here in scale is 18 inches by 18 inches. It might be 24 by 24, it might be 30 by 30, it might be 24 on the bottom and 18 in the back. Why? It depends on the nature of the site and what's coming to us. Of those 6,000 maintenance operations we've done, we separate them into commercial, residential, and industrial. We separate them into small commercial, medium commercial. We learned who was producing the most sediments, who was producing the most trash, and how to make our designs integrate into those systems properly. Okay? So, this trash basket changes in size. It can change in mesh. We have changed them after we put a design in the field. Why? Because we have a warranty. Because we have a long-term relationship with the owner. Because it's our job to clean up his water. It's our job to have a sustainable system. That's why we issue a warranty. This trash basket can be removed for cleaning, and it is removed for cleaning. After the trash basket, we have baffles. These are perforated baffles. The most often comment I get, I'll save someone from embarrassing themselves and asking me why these baffles aren't solid like our competitors. If water's going to go from here to here through my baffle, the water's going to go through the baffle. It's going to go through these holes. This is 66% air and 33% metal. If you look at it, it's just a bunch of offset holes. Every time it goes through a hole, it creates turbulence. The hole's round, so the turbulence is created in every possible direction. If you're a physicist, the net result of arrows in every direction is what? No turbulence. And you'll see this milk, when I pour it in here, lay down and go to laminar flow at the critical point in our device. Extremely important design feature. But if we put a solid baffle here, the water would have to go from here to here, how? Up and over here. Given that it's going through the device in the same amount of time, it would have to do what? It'd have to speed up because the path is longer to get from here to here. Okay? So, we don't make that mistake. You'll see devices with solid baffles. If you understand fluid dynamics and hydraulic design at all, you will probably not want to be using that product because it defeats the purpose of having a baffle. We have this spill protection reservoir, told you about it earlier. Oil can be skimmed into here, shot in the dark, but it does happen. It certainly will catch a spill, but it serves as a barrier, it's sealed, that forces the water underneath and up through our flapper in the back. The flapper. This is, according to my patent attorney, the strongest and best thing we did. I tend to agree with him because if anybody's going to copy anything we do, they generally go after this type of concept. The patent says it's a tilting fibrous filter. The reason we have a tilting fibrous filter is when the Griffin test came out, I was a brand new company. I think it was our 11th or 12th device that we had tested by the EPA. Pretty young company at that point. But they told me, you need to put a filter in your device and then we'll put you in the program. Think about this. They were offering me $500,000 worth of testing for free. The credibility of having an EPA verification certification for free if I put a filter. And in my infinite wisdom, having had an engineering business for 20 years, I said, you know, can't do it. Just can't do it. Can't put a filter in stormwater. And I explained the whole story to the guys. It's like a beaver dam. It starts out porous, but then it plugs up, and it plugs up, and it backs up, and it floods, and you just can't do it. He looked at me and he said, sure be nice if you can figure out a way to put a filter. I guess we'll just put somebody else in there. So I came back to my partner and I said, Clark, we need to find a way to put a filter. And the rest of the story is we were at a trade show the next day. There was some folks there with a roll of coconut fiber filter they were going to put in front of a catch basin. And their story was, this isn't going to plug up. This will get to a certain stage and it'll still flow water. And I thought, I like that. We put them out in our device and we made it so that when this plugs up, and we hope it plugs up, we hope it gets full of metals and all sorts of material, it can push up out of the way and relieve the pressure. According to my patent attorney, it's a self-regulating valve. And actually, we tested this in the lab. Have you ever heard, as engineers, you've probably heard the term head loss? All my competitors have head loss. Why do they have head loss? Let me use X-Scepter for an example. 18-inch pipe in, what's the first thing you see is a little 6-inch pipe going to the bottom of their device. The velocity of the water in the 6-inch pipe, a lot faster than an 18-inch pipe to start with. But that produces head loss. Head loss. Every device out there, you just name them at your will. Every one of them has a constriction in the device. This constriction here, my constriction, 5 times bigger than entry pipe, no head loss. The concern from everyone was, John, I hear the tilt thing, but surely it produces head loss. We went to the lab, we tested, no flapper, tested the head in our device, no head loss. It's hard for engineers to accept, but that's just a fact. There is a loss, it's called an outlet loss. Every structure has it, every round structure, every rectangular structure. It's harder to get water into a pipe than it is to get water out of a pipe. That's about the easiest explanation I can give you. You engineers understand exit losses, but we don't have head loss in our device. So the water comes in. I like to tell people I can do this seminar. We can eat some pizza or barbecue really fast. Goes in dirty, comes out clean. What else do you need to know? We'll handle the details for you, and that's CrystalStream. We're going to design it. We're going to give you your designs. We're going to give you your calculations. We are going to take responsibility for the drawing. We're going to take responsibility for getting it assembled on your site. It's not we send you the parts and you make it work. We send you a functioning device. 1 hour after we get there, if it rains, this device is functioning. Screen the trash, keep it dry between storms so it doesn't rot. Baffle the water, produce laminar flow, slow it down, slow it down, slow it down some more. And on the way out, let's grab all the bad stuff we can with this until it plugs, which it will one day. And then it can flap out of the way to let that water pass unimpeded. I'll have to tell you, almost always, these are still working when we go to clean them in 6 months. Somewhere, someday, a year, 2 years, this will become dysfunctional. And that's why we change it every 6 months when we go out and clean it. I was at Hughes, Good, O'Leary, and Ryan. I tell this story because I can't find the girl anymore. I should send her roses every day because she asked me, after I said people could ask questions, she said, I understand the red dye, but what would happen if you poured milk in it? And I didn't pour milk in it during that time for my demos. And I said, well, it's a colloid, ma'am, and we wouldn't catch it. And I started going with my little talk. She raised her hand again. She goes, and she didn't just say it. She said it really kind of smart like. She said, well, have you ever poured milk in it? No, ma'am, I really haven't poured milk in it. But I can assure you we would not catch it. This would all turn white, and it would come out the back. And I thought the matter had been dealt with, and I was getting ready to go on and finish up my lunch and learn. And she raised her hand one more time. She said, well, I've got some milk in the refrigerator. And at that point, I knew that we were going to pour milk in the device in front of about 50 people, and I was going to have to deal with the results of them watching my device not work. And she did pour the milk in it. Now I've got it running pretty fast here, and I'm going to take a leap of faith and go ahead and pour the milk in at this speed. This pipe is pretty close to quarter full, which means this is running certainly at the water quality speed and scale, maybe a little faster. It would be prudent for me to slow this down, but I'm not going to. I like to take a risk every now and then. So we're going to pour the milk in here and let you see what happens with my device at the water quality speed. When it encounters material, it cannot settle out. By the way, I called my patent attorney on the way home and told him he better start changing his drawings because neither one of us understood how my thing worked. Part of what you'll see immediately is that there is more turbulence here, of course, than here. That's the first thing. The second thing you'll see is that this milk is beginning to lay down on the bottom. You'll also see there's some clear water right here in the beginning. And can you see the milk starting to kind of curl back toward the front? And the reason is, hydraulically, when you expand a conduit for water, you create backflow. Everyone understands that. And here, there's no weight keeping this material on the bottom. It's being kept on the bottom because water is flowing from the back to the front of my device at all times. So, a small particle, and by the way, now that the milk has touched the back of the reservoir, you can see that it's being pulled back to the front. Every time a particle gets in my device, especially the small ones, it might have 4 or 5 chances to get caught before it finally makes this move. And I can tell you all day, watching this speed right here, how slow that 1/10 rise is. But in your imagination, remember I'm in scale here, okay? At the velocity you saw that milk go up, is any of this sand ever going to go up my back wall? And the answer is no. The answer is, in my EPA test, with sand half this size, about 60 microns, we caught 98 of it. So I know for the things that are bad in stormwater, we're well into the 90s. We've tested into the 90s. 89% one test, 96 the other test. And this is an integrated system. Now why? Is this because I am exceedingly clever and we thought of something wonderful? I did avoid the mistakes of some of my competitors who put small constrictions in their device. That's an obvious mistake to someone that's in the separation business, okay? But that's not the thing. I want to go back to what I told you in the beginning. That is the entire message you need to get from me today, okay? And that message is this. Silk fence, CrystalStream, all of my competitors, or anything you want to put out on the ground. Design, installation, and maintenance. And when you see a competitor, whether it's a wet pond competitor, a sand filter competitor that's being promulgated by a regulator, or whether it's an acceptor or a day saver or whatever else it is you want to try to look at, if they cannot sit in front of you and go, here's my plan to take care of your owner long term. We're going to design this machine properly. We're not just going to take a wide guess at your problem. We're going to design it properly. If that means looking at everything in your system, that means I'm going to put a PE specifically on your job. And as engineers, that's what we want to do. We're applying for a job here. We want every job you design. We want a CrystalStream on them where they can be approved and where they make sense. We're going to design it on a site-by-site basis. We're going to make sure it's installed properly. We're going to check it. We're going to hand it off to your owner with a 5-year warranty and a guarantee that this product is going to function. Why? Because we will show up and we will clean it, and the maintenance costs will be known up front. And that's the difference between CrystalStream and the rest of the pack. I really appreciate you giving me the time to sit here and talk to you today about this. But if you don't remember anything else, if you forget about the flapper and keeping the trash dry and how organics collect metals, you remember design, installation, and maintenance is what are the credentials that are necessary for someone to do water quality in your project, whether it's CrystalStream or anybody else. And that's the message I want to leave with. Thank you very much. I appreciate your time.